ஜஸ்ட் அ பாயிண்டர். ஆடியோ கிளியரா இல்லன்னா டக்குனு மைக் அன்மியூட் பண்ணி சொல்லிடு. டிலே பண்ணிட்டு இருக்காத. நான் பேசுற நிறுத்தலாம் பார்க்காதீங்க. டக்குன்னு சொல்லிடுங்க அது.
Hello everyone, good evening to all.
Hi.
Yeah, this is a day 2 workshop. Welcome back to day 2 workshop of our CoppeliaSim robotic workshop. And I hope you all had a great time exploring the software and engaging with the task we discussed yesterday. And before we dive into today's exciting session, I want to take a moment to appreciate the efforts you all put during day one. It's always inspiring to see learners take initiative, especially when it comes to simulation and robotics. Now, I would like to give a special shout out to those participants who successfully completed the task we gave yesterday. We should appreciate them. A big round of applause to Sai Krishna, Gayatri, Sandhya, Hemavarshini, Prasida Sri, Kumar, Danisha, Kalyan Chakravarti. Excellent work, everyone. Your dedication and curiosity are exactly what this field needs. And we really encourage everyone to keep up the spirit we have. We move forward. And let me talk about today's session. Today's session will take things step further. We will be diving deeper into Lua Script programming in CoppeliaSim software, and this will be a very interesting session. And we will start today's workshop. Okay, over to Jason now.
Just a minute, guys. Okay. Good evening, all. Welcome to RCS Workshop Day 2. My name is Jaishnu, and I am here to give you basic ideas on what Lua Script is and how it is used in CoppeliaSim. I hope you are doing fine, and let's dive into what we are going to see now. Now, in this workshop, we are going to see what Lua is, where it is used, how it is used in CoppeliaSim, and what is the basics of Lua, followed by simulation example. Now, let us see what Lua is. Lua is one of the high-level language, just like Python and C++. It is one of the efficient language. As one of the reasons is, it only has one data structure called tables. This language is also fast since it is written in C language. It is mostly used in embedded system. So what will be its applications? Since it is mostly used in embedded systems, so of course it will be robotics and simulation. It is also used in game development, web development, and also in API. For coding, we need a base environment to code, right? Here in CoppeliaSim, we have used scripts for coding. And these are the four main basic scripts in which CoppeliaSim provides for us to code. Add-on script. Now let's just take a real life example or analogy to understand this even easier. Let us take a movie set where there are directors, actors, set designers, and many more people, right? Directors calls the entire movie and ensures whether everything is perfect. And that is what the main script does. It controls the entire scene. And it is not recommended for beginners to customize this. Now, we have designers who prepare the entire scene, costumes for actors. And once the movie starts, they just move out. Now, this is exactly what customization script is. It is used to add custom buttons, UI feature to scenes, etc. It runs once per simulation, and once it runs, it is terminated. We know some people find perfect spot for filming, right? And that is exactly what add-on script is. It is used to customize simulation software itself, like CoppeliaSim itself. We can also take another example like when we use a mobile phone. Now, just for an example, let's consider that we don't have a calculator. So it is not easy for us to do calculations, right? So we can install it from Play Store, then we can calculate. So it is just an add-on script. When we take add-on script, it gives extra features to the software itself. By running certain scripts, we can add even recording features in the CoppeliaSim itself so that We can even record the scene while we are executing the scenes. Here we are mainly going to see what child script is. It is just like in the movie, actors who follow only given scripts, right? They know their role and not the entire scene. Just like that. Now, let's see how child script works. And this is what we are going to do Lua script coding. What is child script? It is attached to an object in the scene, where in the in revolute joints, cuboids, shapes in that. And what's that purpose? To control its behavior and manipulate its working flow. It usually runs during the simulation itself and automatically executes in an order. Now let us see. Let's start with the basics of Lua. And these are the contents we are going to learn in Lua. We first need to know how it works, then only we can code, right? First, let's see what basic syntax is. Basic syntax is how we type what is the general structure of the program itself. And now we will see the syntax in every other types in data types, operators, control structures, functions, and tables. Variables and data types. These are the common data types that Lua scripts provide for us. They are numbers, string, boolean, nil, and table. Numbers can be both integer and float. Integers are round numbers like 2, 3, 4, 5, or even negative integers can be. We can say that as an example. Float is what value it comes with a decimal point like 2.56, 3.58. String is a text. It is mostly enclosed within two. Let's see the example. Boolean is whether we have true or false values. Nil means representation of no value. And another main point, all variables are globally by default. That is, unless we mention them local, we can just use them in any function after declaring it outside all the functions. Now, this is a common example of data types. Here in the right hand side, we have the data type, and left hand side, we have the variable. Radius is a variable. Okay, let me just say what a variable is. Variable is like an empty container which stores the value in its right hand side. Here number 5.5 is stored in radius. When we call radius, it automatically takes the value 5.5 inside it. Similarly for name, here we are storing robot1 inside it. Like is moving is equal to true, direction is equal to nil. And table is also a data type. Now let's move on to the next topic. That is operators. We have three common operators here. Arithmetic operators, comparison operators, logical operators. So what is arithmetic operators? It's like symbols in our calculators, right? Yeah, it's mathematical symbols used for calculations. In arithmetic operators, we have addition, subtraction, multiplication, division, modulus, and exponential. It is mostly used for simple mathematical calculation. Here we have comparison operators and logical operators. Comparison operators can also be called as relational operators. These are mostly accompanied with control structures and functions sometimes. Now we will see example on how this works. The first two lines we have arithmetic operation example. Now if we have comparison, as we can see a is equal to 5 plus 3 is equal to 8. This is basically when we type 5 plus 3, value 8 will be stored in A. Similarly 10 modulus 3 is 1, where 1 is stored in B. Now using above that, we can see the comparison example and logical example. Now what will be the output for the comparison operator given there? Any idea? Okay, let me just give you a basic idea on what are these comparison operators. This is relational, this is not relational, greater than, lesser than, greater than equal to, lesser than equal to. These are basically like if both the values are same, relational will return as true. If a value is true and another value is false, it returns true. If both the value are same, it will return false. This greater than symbol is used to find whether the left hand side is greater than right hand side, it will return true. And for the next one, lesser than symbol, if left hand side is lesser than right hand side, it will return true. In greater than or equal to, if both, it can either be greater than the other value or equal to, then it will return the condition true. Lesser than equal to, either it can be lesser than or the same value, it will accept it. And logical operators are mostly used between two comparison operators. We will just see the example. Here you can see a comparison operator and another comparison operator. Between these two, we use a logical operator. And in logical operators, we have and or not, right? For AND condition, only when both the conditions are true, then the true block will be executed, else the block will be skipped. And if we use OR condition, either one if true, true value will be executed, true block will be executed, and not we only use one comparison operator. And if the condition is true, then it won't execute the answer. If the condition is false, it will execute the true block. Yeah, just not. That is what not is. Now let us move on to control structure. In control structure, we have two types, control block and loops. In control condition block, we have if else, if else, and in loops we have for, while, and do while. Let's just see the basic syntax of them. And this is the basic syntax for the condition block. If condition then code. Like if we here we have the condition, right? We can either use the logical operator or the relational operator. Both will works fine here. Like if gray is greater than b, then the condition code block will be executed. If the condition is not satisfied, it will move on to the else if block. Now we may have some other condition or same condition with some modifications. Then it will go, if the condition is satisfied, it will execute the code block, or else it will move on to the else block. And I forgot to mention you the one main point. In every block, like control structure and functions, we have end block, which is used to close the block of the code. It's like saying, I finished this block, so I am done with this block. This end is used to represent that. And let us see some examples soon. And first, let's go on for loop, then we will see the examples for the if block and this. For I is equal to start, stop, step, do, code block, end. That is, it was like iterating. I is equal to start. If we take one, then till the stop condition, it will execute the code block. Then it will execute the end and it will skip the control flow. Now for I is equal to 1 hashtag flows, this hashtag is used for tables. I will soon tell that what that is. This is another example of for block. Now let's move on to repeat and while. Repeat condition until, repeat code until condition, right? It is similar to a do while. That is, it doesn't check whether the condition is true or not. That is what a repeat is. First it will execute the block, then check whether the condition is true. That is what a repeat is. And while block is a normal block, like a normal loop block. While if the condition is satisfied, it executes do the code. That is what it says. Then after the code is done, it will move on to end. Now let us see some few examples here. Now let's assume speed is greater than 2. Okay. Now let's assume speed is equal to 1.5. Which of the blocks will be executed? Guys, any idea? Even you can chat. I will see the chats. Now let's assume speed is equal to 1.5. Let me wait for 5 seconds, then let me just continue. Else block, if speed is equal to 1.5. Yeah, that is right, Priyadarshini. Darshini shall. What is slow? Fine, then let's move on. If else. And here I forgot to mention another point. For I is equal to 1, 5, do print step. Okay. Here in the Lua script, iteration starts from 1 till n. Like it goes from 1, 2, 3, 4, 5, like that only. Whereas we see in Python, it will go from 0 to n minus 1. But let's just focus on Lua here. For I is equal to 1 to 5, do print step I. Here the output will be like 1, 2, 3, 4, 5. Here similarly, we have a while loop. Now let's move on to the next concept. Now let's see how a function is created. A function in Lua script helps reuse the code and modelize logic. That is, if we declare function once, by just calling its name, we can code continuously without any problem. Just a minute, guys. Okay. I think my network got a little slow there. Function's advantage is that we can reuse the same block by just calling that function name. And we can adjust the parameters in there. Let me just show you the syntax first. Function name, parameters, the code we want to type in. As I told, end is used to declare that I have completed this block. Function is a keyword. Function name can be user defined like greet, help, or anything, whatever you wish. Parameters are like the basic conditions we want or values we pass inside. Code can be used to process what we want and end. Now let me show you some example. There are two types of functions, function without return and function with return. In function without return, let me just first tell you function greet name. Yeah, another point. We use two dot operator in order to separate a string and a variable. In Lua, we use that. That is the what we use in Lua. Now let me say function greet name print hello name end. Now when we call this greet, it will be like hello robo. And in function add a comma b, return a plus b end. Result is equal to add 3 comma 4. The result will be 7, and by using the result word, we can also take it for further calculations, or we can just write print results so that we can get 7. In function without return, we don't store any variables or we don't get any return value. And in function with return type, we get the sum result and we can use that to modify the further code. Now let's move on to one of the main data structure, tables. Tables is the only data structure in Lua. It's flexible, dynamic, and central to Lua programming. That is, every data type like array, dictionary, list is stored inside these tables. And as I told, index starts at 1 even in tables. In loops, in tables at all, we start index at 1. Now these are the common examples in tables. Array style, dictionary style, mixed. Fruits, apples, banana, mango. Yes, here you can see we use fruits iterate one, like, right? So it will only return the value apple here. And mixed type, we can have both the string, we can just store whatever type of data type we want inside this tables. Like I use string, number, key value pair, and also an array. Let me just tell you what a key value pair is. Robot is equal to name is equal to alpha. Here we have name is equal to alpha, right? This is called key and this is called value. By calling just the key, value will be automatically called here. If I type robot.name in print statement, I'll get alpha as the output. Now let us move on to the main part, that is coding. Functions syscall init, functions syscall actuation, functions syscall sensing, and functions syscall cleanup. These are four main functions used in Lua Script for coding on today's workshop. And I believe everyone have completed the bot given previously, right? I just need some responses whether most of you have completed the bot that is given in second day. That
Yes,
is
we have.
day 1. Okay.
Yes.
Yeah, let me just say first. Now let's go for the two functions syscall init. Here syscall init is like initialization of the block. And you will soon learn why I use this. Circle time I'm here using circle time, how long the object is going to be simulated. Start time is used to measure the starting of the object. Motors, I'm getting all 4 revolute joints for this. I gave custom names for that and I will show you how to give that. And I'm giving particular speed for left and left top and left down. I'm reducing the speed and I'm increasing the speed for right up and right down. So I can make a circle using that bot. And finally, I'm just printing a statement to show that the time has started. Now let's move on to next block. That is function syscall actuation. Syscall actuation is just as the name says, it's used to start the work, like activating the rotors or wheels. Here current time, I'm again getting the time so that I can keep track of how long it has passed. And here I am using if block to compare the condition, like if elapsed time is less than circle time. If it is within the 30 seconds, I am using the loop to just assume it. Here set joint target velocity. I'll soon show you in the CoppeliaSim environment how this works. I'm just keeping the motors and speeds like, just a minute, let me show here. Here are the 4 speeds and here are the 4 objects. Left up 1.5, right up 2.5, left down 1.5 and right down 2.5. These are the 4 values I'm using inside here. So left up will be assumed 1.5, right up 2.5, right down 2.5 and left down 1.5. If after 30 seconds, I'm going to just make the speed 0 so that I'm just using another block else. Once 30 seconds has passed, this condition will not be true. It will move on to the else block. Here in the for loop, again I am calling 1 to 4, sim.set joint target velocity, motors are 5, setting the speed to 0. And your first one tells us how we control the bot, which one we are selecting, and second one tells us how much speed we are keeping it. That is what set target joint velocity is used. Sorry for that. Let me just move on to the syscall sensing. What is this? Okay. Functions syscall sensing. This is used to sense whether 30 seconds has completed and the bot is stopped. We can also make it, this is mostly used for sensors operation, but here I'm just giving you basic overview of how to use Lua Script. So I'm just sensing whether the bot has stopped after simulation. After the time is up, it will just print the statement time up, stop circling. And here also I'm using current time get simulation time. It gets the starting time of the bot. And I'm here also calculating elapsed time. Now let's move on to syscall cleanup. This is the final part of the code, like functions, syscall cleanup. It is used in every block of the code in robotic simulation, but here it is used just of four wheels, all the four wheels. I'm going to make the velocity of all the four wheels 0. I know we already made it here. I know we already made it in the syscall actuation itself, but just for confirmation, I am again doing it in the syscall cleanup. Okay. Now let's go on to, now just a minute. Let's go on to the CoppeliaSim. Let me just set my environment a minute. Yeah, let me just go here, hit the screen, share. Yeah, this is the same what you made yesterday. I'm going to just add a script to it. And this is so basic that anyone can even easily code this. But I'm here just going to copy paste the code. So, okay, now let's start. Is it visible? Oops, I can't see.
Yes, it is.
Yeah, okay, thank you. Let me just continue my script. To add a script, you have two methods. Either you can just select here, add, or you can also go here, add. I'm just going to select the object to which I'm going to add the script. Here, add. I know primitive join, we don't have any work here. Let's just go down, script, simulation and customization. Simulation script is just a child script. As we already told, child script is used to control the behavior of the object to which we are attaching it. Now, what is threaded and non-threaded? Just a simple note let me give you. Non-threaded is mostly used for simple quick actions like moving and sensing. It is used okay, now threaded is that it's better for a step-by-step task like move, wait, and turn. That is, non-threaded can be used for simple actions now we are going to do. Threaded is usually for making key bindings and the code is more complex since we are simulating it in real time. And also we use threaded for waiting for 5 seconds in real time, not in the simulation time. Non-threaded is simple. The code is really simple and non-threaded. That is not complex. Let me just take the script. Always make sure that script is attached to the cuboid. Now double tap on that. We already have function syscall in it, right? I believe my teammate has sent the code for that in your WhatsApp group. Okay, by the end of the meet, we will send the code for this. Okay, now function syscall in it. What I show there, I will just copy paste it because I may struggle when talking and typing. I just typed this already and it has it ready for you. Functions is called in its circle time. Yeah. Let me just give you a quick overview. Be sure to change your revolute joint names to this. Or you can just change it here. It's your wish. But make sure of one point. If you are putting this as left down, then this must be left up. Don't change the order. I know this is silly, but we must be sure not to make mistakes, right? Left up, left down. I had given this as left up and left down. So this will be right up and right down. Also, if one side you choose top, make it sure the other side is also top. This is silly, but be careful. Because most of the time, even I made mistake for the first time. Or be careful also here too. For left top, you need left top and down. I'm reducing the speed, and right top and down, I'm increasing the speed, so it will make a circle. That is our actual goal. Now, function syscall in its circle time, 30-second simulation. It's used to start motors, okay, speeds, okay, start circle time, okay. Oh, let me just finish. It is not necessary to run it every time, but okay, I'm just showing it here. Whether I have any errors, let me just check it too. Now let's move on to functions is called sensing. Yeah, let's just copy actuation. It doesn't matter in which order you make because both of them will be same anyway. Functions is called actuation. Current time, as I told, it is used to correct the current time of the object. Elapsed time is calculate the difference between the start time and the current time. And if condition, then code block. As I do, for I is equal to 1 comma 4, do sim set joint target velocity motors of I. By selecting each of the motors, it will just give us the speed 1.5, 2.5, 1.5, 2.5. It will assign accordingly. That is why we had used loop here. You can either use this or you can just type manually like sim dot set joint target velocity, like sim dot set joint target velocity every single time. It's maybe you can do this or you can do how I did. So I can reduce the number of lines of code. This is what syscall actuation is. Now let's move on to syscall sensing. And here again I use this. It is not necessary to repeat again and again, but to prevent any errors and any faults, I just gave it again and again. So it's called sensing if, okay, this is the condition to, and here another point. I can just add put if elapsed time is greater than or equal, that is after 30 seconds, the statement can be printed. The reason why I added it is, I will show you. If I remove this and run it, still the code will work. Just a minute. No, first let me just complete the code, then I will show you. And finally, syscall cleanup is used to clean up all the code. That is, if it has any error, it will just clean up. Yeah, now the code looks okay. Syscall actuation is used to control how the bot works. So this is the only main part we must remember. Now let's run the code and check whether it works properly. Okay, why is it not working? Hmm. Guys, do you have any idea for this? What? After 30 seconds, it starts to work. What may be the issue in the code? Any idea, guys? Oops. Yeah. Document of the code. Okay. Do any of you have idea why the code is running after 30 seconds? Just a minute. Yeah. I think there is some error here. Can any of you tell me?
Guys, the same thing we are saying for all days. You can unmute whenever you want. Say whatever you have thoughts about this. Just open your mic and say, or if it is not possible, just comment.
Just comment also. I will also read the comments too. It seems like you still don't get the basic concepts here. Okay, fine. Here in the elapsed time, I told in functions is called actuation. It controls the bot's movement, right? Okay, Karthi, any idea? Seems like even Karthi and Venugopal is also not sure.
Rajeshnu,
Any idea why the code is not working?
then less than simple.
Yeah, let me just try that. This is, you can just close the script after typing. It won't erase. Yeah, that is the error we had. As you can see, it is all. If you guys already know Python basics, you had already learned this. Or even in C++, we get these basics all the time. And after learning some basic concepts like this is very simple concept. I'm just telling you the basic concepts what you need for this. And I had also made something fun for. I tried to teach this, but this concept I can't make this stay in the same place. So I just made it like go up and down. And yeah, for here today's assignment is in this car modeling circle. Yeah, another point when a script is running, you can't change the script. Let me just repeat that. Today's assignment in car modeling cycle. What is this? this called? Okay, car modeling circling. You must make this board to do a square or a pentagon, anything, or triangle too. If you can make first try the square, it is somewhat easy. Then move on to the triangle. If you are possible, also try the pentagon. This is the assignment for today. Yeah, and something we got the scripts, I think. Yeah, let me just give you some replay on what happened. Yeah, we know this. I think we know what Lua script is and where this is used. And these are the main types of scripts. As I already told, this is child script as it is used for how the object behaves and how controls the object. And in child script, we have four main functions like syscall init, syscall actuation, syscall what is that sensing, and syscall cleanup. Whereas syscall init is used for initialization, syscall actuation is used for actuation. Now let's move on. Let me just give you how the drone works. Yeah, let me just show you how did this. This is the basics of what I did in drone. Function syscall init. This is for initialization as I told. I used to name this block as rotor and this is revolute joint. Okay. This is the top cuboid. I named this as cuboid, revolute joint and rotor. And for rotor, I use sim.get object to get its handle so that I can manipulate the rotor by just using this word. And joint is used to get the sim.get object so that I got the handle of the revolute joint inside the joint. And in sim.set joint target velocity to keep it continuously spinning. Here I'm just using it to show that it's spinning. Another main thing is always remember to keep the object in force here or velocity. It's not a problem here. So let's move on to actuation part. For function syscall actuation, I'm getting the simulation time here. And local position, I'm using local object here. Like sim.get object position, yes. Without the object position, we can't use the upward force. And sim.add force and torque, yes, I'm using this for this task. And rotor 0, 0, 27. Actually, I didn't use a calculation for here. The values are given in Newton. Like first one is use the object, and the second one tells us what is the force we are applying, and third one is the position of the object. That is the main focus here. And if the position and here the values I'm using are calculated in meters. If the z-axis grows greater than 4 and it is less than 10 meters, it will just fall again and again fly up. This condition is somewhat confusing even for me. Now let me just ask a question. Like, how else we can type everything like sim.set joint velocity? Do you have any other idea for making the code even shorter? Or let's move on to for I is equal to 1, 4 sim set joint velocity. Left top, right tops. We can change the simulation time with here. If we move on to that, let's just analyze what all I had done. Now, like I set the joint's dynamic property to velocity. Let's just try well what will happen when it is in free. Yeah, since we are just rotating it without any main problem, it's still rotating without any problem, even in freestyle. Sometimes if we do that, if we try to do that in project trial, that is a drone model, it breaks. Since it's a car model, it doesn't break, I think. Just a minute, guys. Let's move on to the another. Let's just have a small recap here. Yeah. If condition, if block, for block, while block. These are the basic functions used here. And these are the function with return and return without return type and tables. And this is one of the main concepts used here. What is this? I don't need this. Then see array style, dictionary style, mixed style. It's like functions, syscall init, syscall actuation, syscall sensing, and syscall cleanup. Now, let me just ask you guys, do you have any doubt in the coding part or anything? I think I covered today's lecture in most of the parts. Just a minute, let me just show you the script. Let me just take this, let me just, oops, it goes entirely. Okay, let me just paste it here. Do you guys have any doubt in the coding script? And yeah, we will send the code so you need not worry. You can just copy paste and try it, or you can also type it on your own.
Guys, if you have any kind of doubts in the logic or whatever you have implemented, just open your mic and ask, because
Or just
just
message, you'll
pasting
just
the,
see even the message. It's not necessary to just open the mic and answer.
yeah, just pasting the code and simulating it isn't a possible correct way for simulating anything or learning anything. So the main thing is to understand whether the code works or not. If somebody asks you to explain the particular code, you should be in a position to just understand that particular code and to say. So that's what the main scope of
That
our discussion is.
coder each part,
So,
although you worked on a cuboid. என்னடா question இது? Prince Kumar, can you just explain this clearly? I can't understand this line. Like you have coded for each part, although you worked on a cuboid. Yeah, just I think I'm not sure whether this is the correct one you're asking, but let me just say the entire main body of the entire block. It is like the chassis of the robot. And in that I have the right rotor, cylinder, that is wheels, and all the revolute joints connected. So just accessing the cuboid, I just got all its handles like left top, right top. I just got all the revolute joints and also the cylinder. And using that, I coded the blocks. So just coding the cuboid, I got the answer. Yeah, what was your question again? Yeah, I worked on the cuboid. Okay. Because everything is linked to the cuboid. Cuboid is the parent block, to say it simple. Okay, now let's see. Just a minute, guys.
guys, yesterday we have heard someone having some errors or problems with the installation or some kind of errors. If it's any kind of annoying errors or like we don't know how to put these kind of objects or go to scene object properties, ask here. And in another
Yeah,
way,
even if you have any problems in the previous workshop days, you can ask now. Now we have some discussion time here. Since I completed little early, because I thought it may drain a lot of time. I think most of the guys already got the concepts clearly. That's why many are not having doubts.
so guys, just open up and say whatever doubts you had. So we got some kind of 12 to 13 responses four-wheeled bot yesterday. So we are very happy to say that. But in the same time, the remaining members maybe we think are having some doubts. So if it's any kind of that case, we are here to clear your doubts. So because tomorrow's session is more kind of application based, so at that time we can't have time to clear these kind of basics doubts. So that's why I'm implementing you ask any kind of yesterday doubts or today logic kind of doubts, anything.
Let me just give you a small what is going to happen tomorrow. Without knowing these basic contents, tomorrow will be a nightmare for everyone. Though for those who already learned Python, you may already be familiar with these type of syntax and other blocks. But just have a recap on what happening. What? Just a minute. Please remember, guys, without this, you can't code Lua. Like knowing the basic data types, operators, control structures, functions, tables. These are the main parts in the CoppeliaSim. No, as we already saw, what are these arithmetic operators? Okay, we cover these concepts. This is a child script, 4 of the main script. And yeah, let me just show you what child script and main script is. This is what we call a main script. Yeah, this is what we call a main script. Nothing, this is not new. And as I told, this is not recommended to modify since unless we know what we are doing. And for add-ons, we can either go here, environment, we can also customize here, or going into the CoppeliaSim folder. For simulation, we have, I believe this was all taught by yesterday's workshop itself. Okay, now already we have created the objects. And if you have any queries, you can post that.
Yeah, once again, guys. So I hope you are all familiar for the assignment.
Let me just give you some ideas. I thought of using the simulation time to move after a certain distance and using the set joint velocity to turn the directions. By changing the space, it doesn't need to be a perfect square. Just make the board to go somewhat like a square. First achieve that, then let's move on to the sharp turns. Because in this CoppeliaSim uses a complete perfect physics engine for these tasks. Yeah, after moving for a certain simulated time, it can move 90 degrees. Or one side full speed, like making left and right, left top and bottom wheels zero, then making right and right, left and bottom wheels, sorry, right top and bottom wheels maximum speed like that.
Yeah, I think I can make it clear. Like if we allow the left side wheels, which is left top and left bottom, to move in a faster fashion, and in the at the same time the right top and right bottom to stop, we'll be getting a sharp right turn as the right stopped. And in a contrary way, if we have right side wheels rotating and the left side is not, we'll be having a sharp left turn. So you have to make logic for that, so that you can implement a square fashion. So going straight and then a sharp right turn, again a sharp right turn, again a sharp right turn up to a particular distance. This is the main logic for a bot to move in a square fashion. If you want to go for a triangle, you have to manage the speeds of respective joints according to the angle of rotation. So for example, if you are going to rotate for a particular angle, let's say 60-degree, you have to make the wheels to move in a particular velocity so that it will turn according to that particular orientation. So that's the main logic you have to think for. As you go higher order polygons like a pentagon or a hexagon, you have to think of an equal. Let's say we are building an which should have an equivalent degree of 60-degree. So we should be like yes, for a hexagon it should be 60-degree. So we should be making like it is moving in that particular fashion. So that's our main idea should be. So for that, you can make your own particular polygon and make your bot move in that particular polygon, or not to be exact. If it is in a kind of that particular way, we'll be accepting that. And top designs, and also the others who have given the designs come to give another particular design for today. So we'll be expecting you guys an extra, what can I say, extra kind
Yeah,
of.
and also Lua script is one of the most scripts used in embedded systems and by many companies. So it is recommended to first learn these basics. With these, we can even in robotics. Please focus on first Lua and CoppeliaSim. This will really be helpful in future upcomings.
So guys, if you aren't having any kind of other doubts, you are free to leave the meet. Yeah, Hemavashini. Jeshno.
Where can we use tables? Tables is a data structure itself. Let me just show you a minute. Okay. Yeah, I got it. Just a minute, guys. Ah. Mhm. Tables is basically used to store values inside it. Like if we compare it with Python, I believe you know Python. This all are tables here. Array, dictionary, mixed, everything is table. We can use it anywhere here. Just a minute, guys. Yeah, and basically in mixed type, we can use both all types of data type in that.
For the code, you can check the group. We have already sent the document of that particular code for both the four-wheel bot and the drone. So you can check that out. And also for the PPT, we'll take that into consideration, and if possible, we'll send the PPT in the group.
Yeah, the meeting is over now.